Hello everyone. In today's lecture, we will discuss the application to the equal area criteria in the unit number 4, that is in the transient set stability. In the previous lecture, we will discuss the what is the basic concept of the equal area criteria, and why it is important. The equal area criteria is generally used to finding out the prediction of that stability. That is the transient state stability का prediction in define करने के लिए equal area criteria का use होता है. Now we have to discuss the different cases or the different applications to the equal area criteria under the different condition of that power systems. Okay, so in that case, the number one case application of that equal area criteria is nothing but a sustained line fault. Second is nothing but the sudden loss of one of the parallel lines. Number third, sudden short circuit at the on the one of the parallel lines. In this in that case, first we have to discuss the short circuit at the one end of the line and second at the middle of the line. Okay, so we will discuss all this application one by one. So let us discuss the first sustained line fault application of that equal area criteria in the sustained line fault. Okay, so whenever the sustained line fault is there, first we have to discuss the one of the infinite bus is that double line circuit of that infinite bus as shown in the figure. Uh, Here the generator should be connected to the transformer, then is the two parallel lines that should be connected, and that fault should be occur at the middle of that line, and is the infinite bus, that is a single infinite bus. A double circuit line of the infinite bus is shown here. Okay, and with reference to this power system, that is the SLD diagram. The equal area criteria of for this system is mentioned in this diagram. Okay, so in this diagram, as we all know, that the power curve showing the generator output curve displacement angle as shown in the figure, normal condition and in the faulted condition. This is nothing but the normal output of the normal condition, and this is nothing but the output for the under faulted condition. That is nothing but the next diagram. Okay, so here the output of that normal condition is nothing but the output of that faulted condition. यहाँ पे दो condition discuss किया है, where is this nothing but the input, that is a input to the generator. Okay, now the sustained fault. This sustained fault line fault means what? That the fault should be always on the circuit. Okay, so the horizontal line distance pi above the axis represent a constant input. Means what? This nothing but here is nothing but a constant input is there on that power parallel. That is pi बोलो या फिर pm बोलो. Okay, this is nothing but a mechanical input to the generator or the input to the generator. Okay, and pm2 is nothing but the mechanical and pm1 is nothing but the maximum power of the under the normal condition, and pm2 is nothing but the maximum power we are getting to the synchronous motor under the faulted condition. Okay, and that's a1 and the a2 is nothing but the area under the curve of abc and the cde. Okay, so initial displacement angle, as we all know, is ready but a zero, and for the maximum displacement angle is ready but what? It's ready but the del m. It's the maximum output we are getting under this. The same under the maximum output we are getting under the normal operating condition, that is ready but the sm. Okay, so this is the power angle curve under the sustained line fault. Yeah, and whereas displacement angle remains zero at the instant of the fault application. Means what? At the fault occur, it's ready but the at the fault occur at the initial load angle condition, means what? Del zero. अब क्या हो रहा है? Initial sustained line fault है. So there is nothing but the accelerating power. Which what is nothing but the accelerating power? It's nothing but accelerating power क्या रहने वाला है? It's nothing but the that is a pm2 minus pi. Okay, is it that? Pi minus pi, where represented by the length of AB. What is nothing but the accelerating power? It's nothing but the accelerating power, or this is nothing but the deaccelerating power. So the AB, this chart is showing is nothing but the accelerating one, and this is nothing but the showing is nothing but the deaccelerating one. Okay, so why it is called as accelerating? Because it's that the input power is nothing but the less than, that is nothing but the less than as compared to the output power. Okay, and as a consequence of the generator should be accelerated, so displacement angle should be decreases. Displacement angle decrease hoga, so obviously operating point moves along the curve from the B toward the C. Means what? as the displacement angle decreases, displacement acceleration हो रहा है, acceleration हो रहा है. When the acceleration should be occur, load should be there. Load should be there. Obviously, that load angle क्या होगा? Decrease होगा. Load angle decrease होगा तो it should be moved from the B to the C. And then the condition should be occur that initial load on the generator will be increase. अब load increase हो रहा है तो automatically load angle क्या होने वाला है? Now the second condition deceleration में again फिर से increase होगा. पहले decrease हुआ, now it's again increase. अब now it should move from the C to the D, and so the D and E is studied by what? It should be studied by the decelerating power. So the greatest value of when the PA occur without motion along with the step during the existence of the fault would be del m about the intersection of the curve as shown in the figure, this one. Okay, so this is nothing but a point that is equal area point where we are getting is nothing but a critical load angle. It's nothing but a critical load angle बोलो या फिर critical is nothing but the power angle, that is the critical angle across this equal area criteria. This is nothing but there we are getting is nothing but a del C. Okay, so that point of C plays a very important role under the faulted condition. Under the normal operating condition, that's nothing but the P is nothing but the is equal to क्या रहने वाला है? P power is equal to PM1 sin of del 1. This is nothing but the maximum power under the normal operating condition. This is under the faulted condition. So the value of the PI which makes the condition occur is called as transient stability limit. So here the PM and as the sustained line fault hai, mechanical load is nothing but the mechanical input to the motor should be nothing but the constant in that case. So this is nothing but the condition under which the point of C is play very important role, where we are getting is nothing but the intersection of that input curve with the faulted output curve. Okay, so this is nothing but a critical angle, and the speed and acceleration become zero simultaneously at angle del m. So speed and the angle क्या होने वाला है? It should be the zero at a point of del m, because deceleration, this is nothing but a deceleration, ये यहाँ पे acceleration. So ये जो point है D, this is nothing but a decelerating power, decelerating का point है. So this is nothing but the AB is nothing but the accelerating power. Okay, so this is the under the sustained line fault condition is there. Now consider the second condition, the sudden loss of that one of the parallel lines. अब क्या हो रहा है? In the previous condition, input power is nothing but a constant one at a and it's nothing but the point of C is playing an important role. Now the second condition of that application of that equal area criteria, that is sudden loss of one of the parallel lines. Sudden loss of one of the parallel lines. So in that case, there's a bit one of the single machine tied to the infinite to the two parallel lines, but that is nothing but the two parallel lines, that is a switch off and it is nothing but the switch on. So two infinite bus that is single machine use किया है, having the infinite voltage is nothing but V at angle is nothing but the zero, and this is nothing but the generated voltage, and this is nothing but the generator, and this is nothing but the load side is there. Okay, and this is PI or the PM. Okay, so sudden loss of the one of the parallel means क्या हो रहा है? There is a sudden loss at the supposed to be the this point below or this point or this point. Okay, of any of the parallel lines we are getting is nothing but the for sudden loss आ रहा है. Sudden loss किससे हो सकता है? Sudden disturbances due to the excitation बोल सकते हैं, या फिर sudden load losses, sudden decrease of the load, sudden switching of that excitation. This is nothing but a different condition under the transient condition, where we are getting a little bit of sudden loss of one of the parallel lines. Okay, so now consider the machine tied to the infinite bus. The circuit model actually is just shown. So what is the maximum power we are getting is very but at a PE1. PE1 is very but what? PE1, it's a for the generator 1, and for the PE2 this is for the generator power angle curve for that generator 2. So the EGV upon XT plus X1 parallel to the X2 sine of del, that is nothing but Px1 sine of del, that is Px2 sine of del. Okay, so this is nothing but for the Px sine of Px2 for the second line, and this is nothing but the first line. So ये हो गया उसका xt, x1, x2, x1, x2, x1, x2, that is nothing but in the parallel condition. Okay, sorry, this is nothing but the transform is that is nothing but the x1 and the x2 is that. Okay, so that is nothing but the PE1 and the PE2. We are maximum power across that line 1 and the maximum line 2. Now condition the consider the power angle curve of this condition. So where the P max to here here in the figure we are observed that here in the power angle curve, that is a bit the P1 and that is a bit the PI is there, and it is the PE1 for the both line, and this is a bit for the PE2 of that line 2. Okay, so here we have to observe that P max 2, that is a P max 2, it should be the less than P max 1. Yes, P max 2 is a less than P max 2, as the xt plus x1 should be more than xt plus x1 parallel to that x2. So thus the system operating under this transient condition transfer the P is equal to Pi at the top of angle on the curve 1. So this study but the del 0 here we are getting is the P2 should be the less than that P1 for the given transient reactance available. Okay, so thus operating it at a point starting from the point of del 0. So for this is that but the switching of offline. अब मैं क्या कर रहा हूँ now switching off line, that is a little bit the switching of that second line. Now switching off second line, so that we are getting is that the electrical output shifted to the core 2 second, that is at the point of B. So from the 0 A to the B, then B to the C. Okay, accelerating energy corresponding to the area A1 is just into the followed by deaccelerating energy, that is repeated del 0 to the day 1, and this is repeated deaccelerating one, and this is repeated accelerating one. Okay, so found such that A1 and A2 should be equal, so that system should be stable one, and will finally operate at a point of C corresponding to the new rotor angle. So the del 1 is nothing but the maximum, and it's also called as nothing but the del 3 critical load angle or the critical power angle, where the ABC deaccelerating power and the accelerating power should be the equal at the value of that pi minus del of 0, because maximum kitna hai pi minus del of 0 we are getting is nothing but that is a del 1 should be the maximum is nothing but the pi minus del 0, where the system should be the stable. So equal area criteria under this condition should be equal when the A1 should be A1 is equal to A2, where the del should be more than their del 1, and assuming the A2 is corresponding the deaccelerating. So A1 and the A2 ये हो गया उसका deacceleration और ये हो गया उसका acceleration. Now the third condition, the sudden loss of that short circuit of that one of the parallel lines, means what, one of the parallel lines में at the one end of the line or at a middle point of line. So just take the first case, that is nothing but the one end of the line. Now the one end of the line means what, it's nothing but the one SLD is there, that two double circuit infinite bus given as shown in the figure. Three phase fault occur at a sending end of the one of the line. मीन्स क्या हो रहा है, सेंडिंग एंड पे फॉल्ट ऑकर हो रहा है. अब सेंडिंग एंड पे फॉल्ट ऑकर हो रहा है तो डजंट नहीं, बट वी हैव टू जस्ट आइसोलेट दैट फॉल्ट एंड जस्ट बाय सिंप्लीफिकेशन. बिफोर पावर एंगल कितना रहेगा बिफोर द फॉल्ट, इट्स बट अंडर दिस केस ऑफ दैट PE1, दैट इज अ PE1 इज इक्वल टू इस केस के लिए और ये केस के लिए. सो P1 EG upon V1 XT plus X1 parallel to the X2 sin of del is equal to P1 as sin of del. Under the occurrence of the three phase line of the end of 2, so that's PE2 कितना होने वाला है, obviously under the faulted condition, that is nothing but the 0, because that is the load, so we are not getting the power across the second line where the fault should be the occur at the one end of the sending end. Okay, so thus the rotor therefore rotor accelerates and the angle should be increases. अब angle increase हो रहा है तो obviously synchronization will be lost. Angle increases unless the faulted is clear in the time. If the fault should not clear in the time, obviously the synchronization should be directly affected, and the angle should again increases tremendously. So to avoid the asynchronism or to avoid the instability, we have to make that fault should be clear within the time, so that the circuit breaker at the board end should be the open at the time of TC, it's nothing but the critical time or critical clearing time, disconnect the faulted line, and that power flow is now restored by the healthy section, that is nothing but the X2 reactance in place of the X1 plus X2. So that's the PE2 under the say under this condition, that is nothing but the what EG multiplied by V upon XD plus X1 sine of del, that is a P max 3 sine of del. This is a condition under this condition for the post fault, and this is but the pre fault. Pre fault में क्या रहने वाला है? Fault that PE1 is a PE1 is there, and the PE2 क्या रहने वाला है? Is equal to 0 under this condition. And under this condition, this is the case is there. Okay, so for the equal area criteria under the sudden loss of that fault occur at one end of the line, here the A1 is ready but accelerating one, and the A2 is ready but deaccelerating one. So the fault should be the occur at a occur supposed to be that del C, so that P max 3 should be more than less than that is ready but the P max 1 is less than P max 1, and now the rotor start deaccelerating. Obviously, what is the equal area criteria? It's A1 is equal to 80. Means what? The area under the curve of that acceleration it should be equal to the deceleration by changing their load angle or by changing their load. Okay, so thus the system will be stable if the deaccelerating area A2 can be found equal to the accelerating area A1 before the reaches the del maximum allowable value. That is what is maximum allowable value? It is nothing but the del of m. ये हो गया उसका maximum allowance because ये del max है. So before the del max, the A1 and the A2 should be the equal. If the area should be equal, then it's nothing but that system will be stable. Otherwise, it should that A1 area A1 depend upon what? Clearing time taken by that A2 of that line to isolate that fault and clear where that is a critical clearing time taken by the circuit breaker to be the stable one. So this is for that at a condition for the one end of that line. Now consider the short circuit at the middle end of the line. अब middle end of the line में क्या होने वाला है? Fault occur at the middle of the line. Means what? Away from the line end. Means what? From the sending end भी नहीं और from the receiving end. The fault is occur at a one of the parallel line of that middle. Means what? एक parallel lines के middle में fault occur हो रहा है. अब उस केस में क्या होने वाला है? उस केस में that is a this is but a P max, and this is the condition is that first should be the star connected in the star delta, and then is but the in the delta one. Okay, so this is the star condition, and this is but the delta condition is that. So A1 and the A2, there is a pre-fault condition of the two line, and now the post fault में क्या होने वाला है? एक parallel line पे fault occur हुआ तो P1 should be there and the P2 should be equal to the 0, and after that during the fault and this is the condition are there. It's a but the del max during the fault at the middle end of that line with del C should be less than critical. Del C should be less than what? It's a but the del CR critical angle time. Okay, so thus the accelerating area A1 correspond to the point given critical angle del C is less than in this case. Means what? That del C should be less than critical clearing angle should be the less as compared to what? Del C. So the stable condition operation del C, that is del 0 should be acceleration should be possible for the del C should be less than what? Del CR. Means what? Del C critical angle del C should be less than del CR. Del C should be less than is nothing but less than del CR means what? Where it's possible to find out the area should be equal to the area for the A1. For the del 2 should be less than del max. Del 2 should be less than del max. Means what? When the del 2 should be less than del max, that area A1 accelerating before that del C should be less than del CR. So इसका value कितना रहने वाला है? Up to the del C, it should be less than del CR. It's a but a critical clearing angle time and it is nothing but deceleration हो रहा है up to the del 2 where the del 2 should be less than del max. Okay, that is a post fault condition. As the fault clearing angle is increases means what del c अपन क्या कर रहे हैं अभी increase कर रहे हैं. अब del c increase करोगे तो obviously क्या होने वाला है, area is increases and find that a2 should be equal to the a1 and that del 2 increases till the value of del max. यहाँ पे a2 क्या हो रहा है, फर्स्ट कंडीशन में del 2 था. Now during the अब fault clearing time, fault post fault time, okay, of that line. So it should be value should be that, so del 2 increases till its value to be the del max. So the maximum allowable, this is not even the maximum allowable for the stability. So the del 2 should be the del max. This is not even the under the stability condition where it can able to increase from the this value to the this value. So this condition is called as equal area criteria at the middle end of that line. So for that case, we have to applying the, we have to finding out what should be the value of that del cr, that is a critical clearing angle. Critical clearing angle, for that case we have to write down that a1 should be equal to what, a1 should be equal to what, a2 for the stability condition. So under this condition a1 क्या आने वाला है, pi minus p max 2 del 0 to the del cr, yes del 0 to the del cr, and second is but a2 क्या रहने वाला है, del cr to the del max, del cr to the del max, what that a2. Okay, whereas del max क्या है, pi minus sin inverse of pi upon p max 3, whereas what is p max 3 from this condition, that is the sign of del. Okay, so integrating why we are solving, we are getting a critical clearing time, clearing angle. Here this is the value of that critical clearing angle where the system should be equal for this angle, that is a angle. Okay, so this is all about the application of that equal area criteria under the three conditions. Under the first is sustained interrupt fall, instant fall. Second is at sudden loss of the one of the parallel line, then at the middle and at one end of that line of that parallel line fault. Okay, so this is all about the application of that equal area criteria. In the next lecture, we'll discuss all about the first the strain equation, that is very much important with respect to the transient stability.